Welcome to Study Loop.
This problem is a series of 7 functions that we need to graph. And all of these functions use either a floor function, a ceiling function, or a combination. So we're just going to take each one in turn. They're not dependent on each other. And we're just going to do a sample graph and see what it looks like. Now for each of these, as you can see, I've done my marks on the XY axis every 2. So each one of these you can see that's the scale I'm going to use for each of these graphs. So each integer along the x and y axis is going to be 2 of these little squares. Okay, so let's take a look at our first one. The floor function of x plus a half. Well, what value of x will put this equal to 0? That would be x equaling -1/2. And it stays at 0 until x goes up 1 full unit from there. So it's going to stay at 0 until x equals +1/2. 1 is a half, that's now going to jump to 1. It will stay there till x equals 1.5, and so on. So this is a nice, neat step function. Okay, and it will go the same way into the negatives. So here's just a little bit, and then we'll keep going in both directions. Okay, our second one. Again, we have a floor function, but this time it's the floor function of 2x plus 1. Well, same thing we did last time. When is this function equal to 0? Well, it's going to equal 0 when x equals -1/2. So this one in red. So it's equal to 0 at -1/2. And it's going to stay there until x equals 0. So in this first one, x would go up 1 unit and the function the y would go up a unit when x goes up a unit. Here, my function is going to increase by a unit when x increases by a half. So it's going to be smaller steps. Okay, when x is 0, the value is going to be 1. And it will stay there until x equals 1/2. When it equals 1/2, now it's going to equal 2. When x is 1, it's going to equal 3, and so on. So these are small little steps, half the size of the steps in the first problem. And it also goes down into the negative values there as well. So it can go both directions. Okay, next function. Now we have a ceiling function. Ceiling function of x divided by 3. So let me set these up here. Give myself a little hash marks on my grid. So what gives this a value of 0? Well, when x equals 0, this is 0. As soon as x is just a little bit bigger, I'm going to have a fraction that's bigger than 0. It's going to jump to 1. So it's immediately going up to 1. Oh, and I want to make this a different color. Let's make this one blue again. Okay. Now, when let me come back up to show. When we had 2x here in this problem right here, the steps were twice as small. You went up twice as fast. Here, I have x divided by 3. So now I'm stretching the steps. They're going to be 3 times as long because I'm going to get all the way out to x equals 3 before I change the value of this function. As soon as x is a little bit bigger than 3, now my fraction's just a little bit, it's going to be 1 plus a little. That ceiling function is going to jump it up to 2. And it will stay there all the way out to x equals 6. And then it will jump again. So as you can see, these are longer steps. Going on the negative side gives us the same thing. And it's going to come out this way. So that is what this function is going to look like. Since I'm dividing it by 3, I'm stretching out the steps. If I'm multiplying it, I'm making the steps shorter. Okay, our fourth one. Now this one is very different because instead of having the x in the numerator like in the last one, x is now in the denominator. So let's see what happens here. Okay, let's focus on positive values. So this function isn't going to exist when x is 0. It's got an undefined spot there. If x is bigger than 1, this is going to be a fraction smaller than 1. Okay, and that'll go for x all the way out as far as I can go. The ceiling of that function will be 1. So as soon as x equals 1, the ceiling is 1, and everything bigger. If x is smaller than -1, I'm going to have a negative fraction that's smaller than 1. The ceiling of that's going to be 0. So it's going to be all the way out this way. Oh, sorry. This is an open circle there. Okay, so those pieces are easy. Now, what's happening between -1 and +1 for x values? Well, let's look at positive first. As soon as x is a little bit smaller than 1, this fraction is going to get a little bit bigger than 1. It's going to be an improper fraction. So it's going to jump to have a value of 2. And it will stay there until x equals 1/2. Then it's going to jump to have a value of 3. And it's going to stay there until x equals 1/3. And then it'll jump to 4. And then when x equals 1/4, it's going to jump. So we're going to get progressively smaller and smaller and smaller little steps, getting closer and closer to the y-axis. You will also see something very similar on the negative side. As x reaches 1/2, and then 1/3, and then 1/4, and you're going to get smaller and smaller steps, closer and closer to the y-axis going down. Okay, so that's what that one looks like. Next function. I have the ceiling function of x minus 2 plus the floor function of x plus 2. Okay, so here's what we're going to do for this one. Because both of these are going on, let's start by plotting what happens at a few integers. Okay, so when x equals 0, this function equals 0. Okay, now how about when x equals, well, let's do it this way. So when x equals 0, the function is 0. If x is just a little bit bigger than 0, it's going to go up to have a value of 1. And I need to put some hash marks on this. Okay, so this one I think makes the most sense if we make a little chart. So I'm going to put a little chart over on the side here. I'm going to have x. I'm going to have the ceiling of x minus 2. I'm going to have the floor of x plus 2, and I'm going to have what they equal. So we're just going to take this top little quadrant here and make a little chart. I'm going to start with x equaling integers, and I'm going to go up from 0 up to 4. That should be enough so we can see the pattern. Okay, the ceiling function, when x equals 0, that equals -2, equals -1, 0, 1, and 2. Again, we're right on these integers. I'm not worrying about the intervals yet, just the integer values. Okay, the floor function, when x is 0, that floor function is 2, 3, 4, 5, and 6. And when I add them together, because that's my f of x, I'm adding these two values, 0, 2, 4, 6, 8. So I can actually plug those points in. 0, 0, 1, 2, 2, 4, 4, let's see, 1, 2, 3, 4, 5, 6. Okay, so I've got the first 4 of those 5 points put on here. Now, what's happening in the intervals? So I'm just going to kind of box these in green. These are the in-between pieces. Okay, well, my first column here, that's a ceiling function. So as soon as I get a little bigger than x equals 0, I'm going to pop up to the next integer. So in that interval, that ceiling function is going to be worth -1. As soon as I pass x equals 1, I'm going to pop the value of that function up to the next integer. So it's going to be 0, 1, and 2. So it always equals that next integer's worth, next integer's value. The floor function is going to be the opposite. As x gets a little bit bigger than 0, I'm going to stay on that floor until I get up to x equals 1. Oh, sorry, I hit the wrong one there. So that's going to stay a 2. Okay. After x equals 1, it gets a little bit bigger. I'm going to stay at 3 all the way up until x equals 2. Then I move up, and then I move up. So you can see the ceiling and the floor are changing at different times. And the values, when I add those up, are in between 5, 4, 5. Oh, and I copied wrong when I did that. So I'm just going to remove these numbers right here. 2, 2, 3, 3. This should be a 4, and this should be a 5. Okay, so this is 5, and that is 7. So you can see those are the in-between values. So when I go to mark those, that means between x equaling 0 and 1, the value of my function is 1. Open circle on both ends, because I already have put in the values at the integer points. Between 1 and 2, the value is 3. Between 2 and 3, the value is 5, and so on. So you can see how I have a range and then a point, a range and then a point, and so on. So that's the value of this one. And again, sometimes the chart, especially when we have a mixture of these, you can see how each of the pieces is moving independently and then put them together. Okay, next one. I think this is probably one of the most complex ones out of the set that we've been given in this problem. So just like the last one, we're going to start by seeing what the values are at the integers, and then we're going to see where each of these pieces change. So when x is 0, the value of the function is 0, because both pieces are 0 at that point. Okay, when x is 1, well, let's take a look at, let's see, the first piece is going to be worth 2. The second one is 1/2. The ceiling of that is going to be 1. So 2 times 1 is 2. So the value of the function at that point is going to be 2. How about when x is 2? Well, I have 4 times 1. So that's going to be 4. 2, 3, 4. Okay. How about we do some negatives? If x is -1, well, I'm going to have -2. And the ceiling of the other one is going to be 0. So I'm going to stay at 0. In fact, that actually shows something interesting. I'm going to be at 0 for a while because of that piece right here. As soon as x gets any smaller than -2, that's going to be 0 because I'm going to be a fraction. And it's going to stay 0 until this piece right here reaches, x has to equal 1/2. Because at that point, when x is 1/2, oops, and that's going to be an open circle. At that point, it's going to be switching. So as long as one of those two is 0, my function is 0. So I've got a good long chunk of time where I'm 0 here. Now, let's let x equal, that is just at -2. But what happens when x equals -2? Well, the right-hand side, or the first one will be -4. The second one will be -1. 1, 2, 3, 4. That's going to be a value of 4. Oop, and I'm over one too far. There we go. Okay, so that's what we have there. Now, what's happening in between? That's going to show us really the shape of this. And this is not a nice symmetrical graph like some of the ones we've seen. Because we have the mix of floor and ceiling with positives and negatives, it's going to be non-symmetric. Okay, so let's look at the positive side for a minute. We saw that we're 0 until x equals 1/2. Okay, when we hit x equaling 1/2, we're now going to be, when x equals 1/2, we're going to be up here at y equaling 1. And we're going to stay at 1 until x equals, just till x equals 2, and then we're going to jump up. Once x is a little bigger than 2, we're going to stay there until x equals 1.5. At that point, we're going to jump up to 3. And we'll stay there until we get to x equals 4. So this first little bit, we have some nice little steps, okay? But then we get a jump, because as soon as x is a little bit bigger than 2, this piece right here is going to go from x equaling 1 to x equaling 2. So now we're going to be doubling everything. So we're going to be jumping fairly significantly. Okay. As soon as we get past that point, we're going to be jumping all the way up to y equaling 8. which is already off our scale a little bit. But let me just tell you what this is going to look like. This piece here, this bit right here from that little bit, those steps are each 1 unit apart because I'm multiplying by that ceiling of x over 2, which was 1. So every step I was multiplying by 1. Once that step is 2, now my steps are going to be 2 units apart. Once I get to that x over 2, once the value of that is 3, I'm going to have another jump, and then my steps are going to be 3 units apart. So as I go up, the steps are going to be getting a little bigger, farther apart, and this jump between the sets of stairs is going to get farther apart as well. And you're going to see something very similar on the other side, just offset a little bit. As you can see, there's no steps in here, even though there are steps on this side. Then I have a gap on the right. That's where the stairs are going to go on the left-hand side. And I'm going to see stairs in this section. I'm rapidly going to run out of room. Then there's going to be a gap while you see stairs here. Then there's a gap and you'll see stairs here. And you'll just go back and forth as I go up the side. So it kind of is reminiscent of an x squared function because I have an x times an x here, but a little bit different because of the floor and ceiling mix. Okay, last one. And let me just put my little hash marks on this one as well. Compared to the last one, this is a much more straightforward function. So here I have the floor of x minus a half. Okay, so that piece right here, that floor, that's going to give me an integer. Then I'm going to add a half and take the ceiling. So if I have an integer and add a half, that's always going to give me something with a 0.5 on the end. When I take the ceiling, it's going to be the next integer up. So you can actually think of this function as the floor ceiling of x minus a half plus 1, because the net result of that plus 1/2 with the ceiling is I'm going to be adding 1 to it. So let's just take a look at a few values. What makes that floor function 0? Well, if x equals 1/2, that floor function is going to be 0, and I'm going to add 1 to it. Okay, it's going to stay there until I go up 1 unit for x. It's going to stay till x is 1.5 and go up. And we're going to have these nice, neat steps. And coming back is going to be the same. So that's this one. Again, a little bit more a little simpler than the last one we did. So these are the 7 functions within this problem.